Bismillahirrahmanirrahim. This is Engineer Masood Akhtar Kiani, and today we have the technical session number 101. This is material name is girder as material in the bridge. So before going ahead, I would like to request you to press the bell icon, like it, share it in order to reach the next video with the easy access. The girder in the bridge is the main material which is bearing the load, traffic load, and all types of the load, and transfer to the other components of the bridge. So basically, this material is casted from the all raw material which are using in the concrete, steel, all the raw materials like aggregates, cements, admixture, additives, steels. All of these are testing in accordance to the relevant standard as testing for the normal concrete. But there is, in additionally, there is a pre-stress and the precast and the pre-stress and the post-tension and the pre-tension. This is the procedure which is used for a backbone of this material. So we will discuss this one. So what is the pre-stress concrete girder? This is the leading choice of the bridge construction across the country, and it is easy understandable that the compared with the other material bridge superstructure is studied pre-stress beam girders and have the long service life and load bearers required. Also, if the maintenance is required, it is a easy factor. So what is a concrete girder? Girder is a beam of a steel or wood or reinforced, but here we will discuss about the reinforced, which is using main in the horizontal supports of the buildings or a bridge. So what is a girder in the bridge? The girder are the simplest bridge types structure and consist of the beam shaped as in one section of box called the girders, and the girders respectively are compared with the deck slab, and which the vehicle and the people passes through in the main girder supporting to the deck slabs. So what is the pre-stress concrete in factor in the girder? Pre-stress concrete girders are a type of concrete girder that facilitates the rapid construction of the bridge using girder fabricated off-site and then transported to the erection place and into the job of the sites by some lifting techniques. So what are the function of the girder? The girder are intended to be primarily structure support, and they have a much larger load bearing capacity and carry dynamics. Rolling girders are also used as structure including bridge, roads, flyover, and the trusses. So what are the concrete beams? Concrete beams is a structural engineering, and a complete beam is a load bearing unit that can be used to carry the both horizontal and the vertical loads. Known as the reinforced concrete beam or the reinforced uh, cement concrete RCC beams also. These beams are made of the encasing in the steel bars, plates, and the fibers within the concrete of the traditional concrete. So why the concrete beam as a pre-stress? A similar fashion of the concrete beam could be held tightly and from the use of the steel and the cables, which is called the tendons. A concrete beam is a pre-stress because the stress is created before or the pre as the actual use of the beam when the working stress is applied. So what is the difference between the girder and the beam? The main difference between the girder and the beam is the size of the component. In generally, Workers in the construction industry refer to the large beams as a girder if there is a chief horizontal support in a structure, it is a girder. If not a beam, it is one of the smallest structure support to the beams. So this is the girder roll and is made of it may be made of concrete and it can be steel and depend upon the design parameters. So whatsoever it is. So how many girders? How to make the girders? There is a formwork of the girder and it can be fabricated according to the design sizes and the parameters. But a girder is a hollow structure and the skeleton made in the steel welded together with the reinforced by the frames, ribs, spacer, and the stiffness. The size of the position is all determined by the sophisticated and load calculation as per the design parameters and the local building codes. The girder may be also made of concrete or steel, but many short bridges, especially rules where it can be exposed and the water overstopping the collision utilize the concrete or the box girder and whatsoever. The term girder is typically used to refer a steel beam, but here also we can use the same terminology. In the beam girders, bridges, the beams themselves are the primary support for the deck and they're responsible for transferring the load down to the foundation material types, shapes, and the all the effects that uh, uh, much weight of a beam can be hold. Due to the properties of the second moment of area, the height of the girder is mostly significant factor to afford its load capacity. Longer span, more traffic, or the wider spacing in the beam will be directly result in the deeper beams. So these designs are of the bridges are the span larger distance without requiring the depth of the beam to increase beyond the particles. However, the inclusion of a trusses and all the bridges is no longer than the uh, girder of the bridge. The bridge consists of the two main parts, the substructure and the superstructure. The superstructure is in everything is from the load bearing pads ups and it's also support the loads and the most visible part of the bridge. The superstructure, the substructure of the foundations uh, transfers loads from the superstructure to the ground. Both must be work together to a concrete, a strong, long-lasting bridge, which always it's play a vital role of the uh, traffic flow and whatsoever it is. So introduction of the pre-stressed concrete structure using in the high strength material and improve the specially ability and the serviceability and the durability factors. The conventional pre-stressed concrete bridges segments concrete also all the bridges are is the cylindrical strength is uh, uh, up to 56 megapascal is used after 28 days. Is- It is acceptable, but it can also be high according to the design calculation and the design requirements and the site situation. But this is just an example. The higher early strength are often needed, however, either the fast precast method used or the production of the plant or for the fast removal of the work and the fast cost the place of the method, the modulus elasticity of the concrete with the density between uh, 14,040, 1440 and the 2500 kg per cubic meter may be taken into account where the water cement ratio is also is very tight. The total shrinkage strain ranges from the 0.004 to 0.0008 over the life of the concrete, and about the 80% of this occurs in the first year. The moisture cured concrete avoiding the shrinkage, pre-stressing uncoated, even the wire stress relief the standards ASTO M203 or ASTM A416 are the low relaxation 7 wires cores, and also high strength bars are the ASTO M275 and the ASTM A722 are commonly used in the pre-stressed concrete and the bridges, but this depend upon the approved method statement by the engineers, and then it is the pre-stressing and the post-tension and the pre-tension is allowable once the approved method statement is approved by the engineers. Pre-stressing reinforced whether the wires stand in the bars is also called the tendons. These properties are the pre-stressing are also grouted after a post-tension construction. When the tendons are to be bound and grout is needed to transfer the loads and to protect the tendons from the corrosion. A grout is made of water and the sand and the cement epoxy resin. Astro LRFD 4 require the protection and the method of the indication where the quoted documents are required. But this is the very serious issue for the these practice. It should be according to the approved method statement. ASTO LRFD Bridge Design Specification First Edition. It is in 1994 official. The is described the pre-extension members also and the post-tension activities where it's can be started after the finalization of the uh, post-tension activities, both activities, pre-tension and the post-tension activities. So this is the briefing about the girders of the bridge, which are mostly producing the load, and also in some provision this strength is it can be go to the 106 megapascal also, but again I will say that it depend upon the design and the span and the heights and whatever the sizes of the girder and the total volume of the load volume of the whole structure. But this is the procedure. So in next video we will see each other with another subject. Thank you very much and have a nice day.